third lecture or penultimate lecture in this series on MATLAB in nutshell. So this is the third part. Then we'll have another part, another lecture that will finish it. I hope you have tried what we discussed last time, the exercises. You have tried to write programs. If it has not been possible, then we will discuss those programs at the end of this lecture. For the time being, let me try to give you some examples with the theory that is involved. So what we discussed last time, same thing with example problems or example coding we will discuss today. So let me start with what is called M files. Last class also I told you that M files are MATLAB files. The extension is .m. So there will be a file name as for your convenience. So give a file name then .m, that is a MATLAB file. These are usually called the script file. And these script files are the MATLAB files. They are a collection of MATLAB commands. MATLAB commands will include operations, both numerical or arithmetic and logical operations, as well as commands, comment lines. So everything a collection in a particular manner or in a proper manner from top to bottom. So start with say x is equal to a, then y is equal to b, then z is equal to x plus y. So this is called top to bottom. So in the top you are saying x, then next line is y, next line is z. So top to bottom. So if you write z is equal to x plus y, then x is equal to a, and then the computer will not understand what you are writing, because for x, z is equal to x plus y, it does not know what is x. You are defining x after this line. So you have to write or define everything before it is used in the program. So that is what is a script file. So as I told you, it is a collection of MATLAB commands. Similarly, there can be a function file, which is a definition file for a particular function. Suppose you are having a function, defining a function add. Add function adds two numbers. So for that you write a script file and save it as add. So that is one advantage of using function files in script file. So your script file will not be very long. You divide the script file into short parts. Use functions in the script file. Like when you are writing a program, uh, suppose you are writing y is equal to sine x. So in this case, sine is a function. For this, there already exists a file, which is a function file. You are not required to write the sine function, everything what is contained in the sine function file or sine, that you are not going to write in your script file. So once you have developed a function file, that function file you can use in n number of script files. There are some inbuilt function files like sine, cosine that we discussed in the last time. All functions, MATLAB functions, sine, cosine, tan, tan hyperbolic, sine hyperbolic, arc sine or a sine, which is sine inverse. All those functions are inbuilt. And you can build your own functions also. So you can, so one is inbuilt, one is user built. So you can design your functions, save it in a directory and use it in the script file. Now let us start with the script file. Okay. Uh, since the script file can contain MATLAB commands, and these are to be in a proper sequence. These commands will be in a proper sequence. So any valid sequence of MATLAB commands can constitute a script file. If you are writing a program, you actually write a sequence of MATLAB commands. So they are sequenced in proper manner so that one after another. So first one is used in the second, then it can be used in the third, so that way. So at line 5, suppose your command is in line 5, then line 5 can use commands which are from 1 to 4, as I gave you another example. Now this sequence will use variables which are defined, or you can define the variables in the sequence at the beginning, and then you can use the variables in other script files. Uh, so these are, once you design them, they become global variable. Global means uh, they are present in the workshop throughout, workplace throughout. So once you have defined it, it is valid. Suppose a is equal to 5. You defined a is equal to 5. Wherever you use a, it will be representing 5, or it will be equivalent to numerical 5. So whether you have written, once you have written it in the script file, executed the script file, then you come back to the command window. In the command window, whenever you write a, it will give you 5. So that is called a global variable. It will not change. It remains as it is. So variables, once you define a variable in the script file, they become a global variable. So they are present in the workspace always. Now let us try to see one example. A linear equation, we'll design a linear equation with a parameter r and try to solve that linear equation. That is the example that we are going to see. So the linear equation that we are trying to see is 5x plus 2y plus rz is equal to 2. Now you can see there are three variables, x, y and z. So we require three equations to solve this. So second equation we will say 3x plus 6y plus 2r minus 1z is equal to 3, and the third equation is 2x plus r minus 1y plus 3rz is equal to 5. So this is a equation. Now in this equation is to be solved for r. So this equation we want to solve using the MATLAB. We'll write a script file and solve this equation to find out which value of r will satisfy all these three equations. That is what is the motto, or that is what is the aim of writing this script file. So let us try to do that. So now you can see what we are doing. First line we are giving a percentage sign, which is a comment line. So that indicates that it is a comment line. In the comment line we are writing this is a script file solvex.m. So my file name is solvex.m. You can give any name, but .m has to be there. You can give any name. Linear.m you can give, uh, r.m you can give, uh, rvalue.m you can give any name there, but .m has to be there. So this is a script file. We are trying to write a script file for solve.m. This is going to solve the previous equation, the equation that we saw in the uh, last page. This is going to solve for x. In fact, this is going to solve for r. And also it will calculate the determinant of a. Now what is a? So the first four lines are comment lines. Then we are coming to the uh, determinant of A, or we are going to define a matrix A. A is equal to 5, 2 into R. Now try to remember the equations that I showed you in the previous page. That was 5x plus 2ry plus rz. So the coefficients of x, y and z in the previous equation were 5, 2r and r. So those coefficients we are putting for the first equation, it is 5, 2 star r. So those coefficients are there. So that forms the first row, 3 columns and first row. Now you can see that equation is, you can write in the form x, y, z can be one column matrix. On its left you can have 5, 2 r, 3, 6, 2 into r minus 1, then 2 r minus 1, 3r. That is a matrix. So that matrix we are trying to write. So 5, 2 r, 3, 6, 2 into r minus 1. These are the coefficients for the second equation. For the third equation, coefficients are 2, r minus 1 and 3 into r. Now, b is equal to 2, 3, 5, which is, these are the values which were on the right side of the equation. For the first equation, it was equal to 2, second equation was equal to 3, third equation was equal to 5. As I told you in the last class also, we are trying to solve the equation ax is equal to b. Now what is A? A is the coefficient of the linear equations. So these coefficients are given in the first line. And B is on the right hand side. So B is a column matrix which is given here. Now what we have to find out is x. Ax is equal to B. Therefore if I want to find out what is x, what I will do is I will multiply on both the sides A inverse on left side. A inverse A is equal to 1. So I multiply A inverse on left side, uh, and similarly on the right hand side of the equality sign. Again I will first take A inverse, multiply that with B, which means we are left multiplying B with A. That is a, as I told you, the writes uh, backward slash or forward slash, that you have to find out. If it is right multiplied, then it is always a forward slash. If it is left multiplied, it is always a backward slash. Now since we are multiplying in the left hand side, left multiplied, A inverse B into A inverse will be B forward slash A inverse. A inverse B will be A backward slash B. So the determinant, first we will find out what is the determinant. Determinant of A is det A. Det is a MATLAB command to find out the determinant of a square matrix. Now as you can see here, A is a 3 cross 3 matrix. So you can always find out its determinant. 3 cross 3 matrix is a square matrix. So its determinant can be obtained using DETA. So determinant of A, you can find out what is the determinant of A. If determinant of A is not equal to 0, then only this equation is solvable. If it is 0, then it is difficult to find out the inverse of A, inverse of the matrix. So it is not solvable. So that is why we always try to find out what is the determinant. If you are solving an equation, linear equation, so we find out the determinant and check it whether it is 0 or not. If it is 0, it is a singular matrix, you cannot solve it. Now you can find out what is x. X is equal to A slash B. What A? Backward slash, not forward slash. Why backward slash? As I told you, backward slash because it is A inverse B. A inverse B in the command form of MATLAB it is A backward slash B, or B inverse A in the MATLAB format is B forward slash A. So it is A backward slash B. So that will give you the final solution. So this is how you can write a program. Now there are some cautions or precautions that you should always remember when you are writing a program or when you are developing your script files. For the script file, the first precaution is never name a script file the same as the name of variables it is going to compute. For example, here we are using A, determinant of A, or we defined A. So this file name should not be A.m, or we are calculating X, so its name should not be X.m. So don't give the same name as a variable to the file. So file name and variables should be different. That is one. Second is yes. Second is just a minute. YouTube is giving some problem, so let me check it. Okay, when you are giving a name to the script file, it must always start with a letter which is A to Z. It can be capital letter, it can be small letter, but it must start with a letter A to Z. Then it can be followed by a digit like 1 to 10, 1 to 9, or 0 to 9, sorry, 1 to 0 to 9, or letters or underscores. These are the three things that you can use for naming a file. Start with a letter, follow it by digit, letter, or underscore, and the maximum size of the name will be number of characters in the name excluding .m. Excluding .m, the number of characters in the name of a script file can be up to 19 characters. Maximum is 19 characters, but you will never require 19 characters. You can at best use 4 to 5 characters usually. So don't worry about that, but it should not be more than 19 characters. So length of the script file should not be more than 19 character. Now after that you have to put .m. When you are writing, in fact when you are writing your program in the MATLAB straight away, direct you go to MATLAB, open MATLAB and write your script file, automatically .m will be added. You need not write .m there. But if you are not using MATLAB, you are writing the program in a text file or in the Word file, that way if you are writing a program, then the extension should be .mem. Otherwise you need not worry about this. Then all variables that are generated by a script file, they are left in the workspace, they become global variables. Therefore, avoid the name classes with built-in functions. So you cannot write a variable as sign. Try to avoid that. Sin is equal to a tan theta. So then it will be confused because sin is also a function, inbuilt function. Tan theta is also a function. Or you can say sin is equal to 5 because sin is a built-in function. If you write sin, then it will get into problem. Because you have assigned sin into is equal to 5, then you go to command window, write sin 30. It will not understand what is sin 30 because you have already said sin is equal to 5. Those problems will be there. So avoid name classes with built-in functions. So remember the built-in functions, avoid those classes with your variable names. So names of the variables when you are choosing, be very cautious or take precautions. Always choose it properly, appropriately. Use the command exit. Uh, then give a name. Name is the name of the file, etc. So use the command exit to check if the name exists or not. So if you are using a name, uh, suppose you are using xyz to define a variable and you do not know whether xyz is a built-in function in the MATLAB. So what you will do is before defining xyz, if you have doubt, you are in doubt, then go to the command window. In the command window, write exist, then within bracket, uh, within exist bracket start, quote mark xyz, quote mark end, bracket ends. Then it will show you whether this xyz is a built-in function or not. So in the command window, you'll see that xyz is a built-in function or not. If it is not a built-in function, you can use it. For example, write sign. So you can write exist bracket within quote single quote sign inside the bracket, then enter. Then it will show you that sign is a built-in function. So you will know that you are not going to use sign. So this is something about writing a script file, taking some important precautions. So we discussed how to write a script file. We saw an example of script file, and we now know some of the important uh, precautions that are required to write a script file. Similar precautions are also required for a function file. So that part remains constant. So now let us try to see how to write a function file. This file is also a M file, which means also has a .m extension, except that the variables in a function file are all local. That means these were the variables within this function file are local to the function file. The moment you come out of the function file, those variables will not be used. They are not useful outside. You cannot use those variables. Even if you can reuse those variables. Suppose you are writing x is equal to 5 within a function file. You are writing x is equal to 5. Then you close the function file. In the script file, you have called the function file or you have used the function file. Then you are going to the command window and writing x. X will not be 5. It will say x is undefined. X will not be 5. Although x has been executed in the function file. So that is a beauty of this, and that is also used in C programming or Fortran programming. So function file variables are local to the function file. They are not global. But script file, once it has been executed, all variables become global. But function file, when it is executed by calling from a script file always calls a function file, or function files are called by the script file. So the variables within the function files are not global, they are local to the function file. So long as function file is being executed, they are there. Once it is executed, those will be erased from the memory. Then function file is like a subroutine in Fortran or procedure in Pascal. You don't know Pascal. Fortran, I hope some of you might be knowing. So it is like a subroutine in Fortran or a function in C. Uh, so this is a comparison of function file with other high level languages or mid level language. You know, C is a mid level language, Fortran is a high level language, Pascal is a high level language. So this is a comparison. Now let us see what is the syntax, how you are going to write a function file or syntax for definition, function definition. So how you will write is function. So starting will be with function. So when you are designing a function file, always start with this. Open the file, write function, then within square bracket you can put output variables. So what output variables means, what are the variables that are coming out of the function. If you execute the function, which are the variables that you want as output from that function, x, y, z, whatever it is. So write that. Those output variables, it can be one variable. If it is one variable only, one output is required from the function, then you can drop the square bracket. Straight right, you can write function, then the name of the variable is equal to function name. Give the name of the function. Then what are the input to the variable? For example, say y is equal to fx. Now what does this mean? This is how you define a function in mathematics usually. Y is equal to fx. In this, name of the function is f. You can also say y is equal to gx. Then the name of the function is g. Then input variable to the function f or g is x, and output of that function is y. Y is equal to fx. You use, for example, you can write y is equal to x square, right? So your f is x square, right? Input is x and output is y, parabola, for parabola. Now let us see in terms of MATLAB an example. So this is an example function row hf. So the output from this function are row hf. Three output variables will come out from this function. This is called to motion. Motion is the name of the function. X, Y, Z are the input variables to the function. So if you give as input X, Y and Z, the function motion will give you output as row H and F. So this is how you define it. So function row HF is equal to motion X, Y, Z. This is one example. Another example is say function theta. This is a single variable. So you can keep this square bracket or you can remove this square bracket, but you have to write function and theta. Remember this function always f is small letter. F is not a capital letter, f is always a small letter. Function theta is equal to angle th xy. So this theta depends on x and y, and it is defined by the function angle th. So from that you are getting this function. These are some dummy examples. Then you can also write function theta, same thing. The uh, line above this shows you function theta. This line also shows you function theta. Now difference between these two is there is no square bracket on this second one, second line, third line. Because there is no square bracket, it means that there is only one output from this function, and the function we are defining here as theta. You can also write it as angle th, not a problem. Now why we are writing theta here? In the second line it was xy, here is defining xyz. So three angles are there, three variables are there, nothing beyond that. Then function, then you can see there is nothing, no output. You can see there is no output. That is called to circle R. So you can define a function where there is no output. Nothing will come back to the script file which is calling it, but circle R, it will design a circle. Maybe you can plot a circle at some point. So that is what is going to happen, but there will be no output from this function. The same one you can write as function circle r. If there is no output, so you can skip that. So write function circle r. We will see some of these examples, but I will like you to read the book if you have found it, Rudra Pratap book, and see the examples that has been done in there. Now let us take notes on some of the functions. So function definition. Unlike other high-level language, programming language, data types are not specified in the argument list and return values. Data type means whether the data is numerical data, which is integer, or real, and that is not required to be specified, or it is character. Whatever is the data type, it will automatically take. You need not specify the data type while you are defining the argument. Argument is fx. X is the argument for f. So that is the argument. So for that argument, you need not define the data type. Similarly, for return values means, as I told you, y is equal to fx. Y is the return value from fx. Similarly, function, uh, then you write anything that we discussed earlier. Function angle. So angle is the return value. So those are the return value. Then MATLAB functions can return a list of values, a vector, as I showed you in the previous slide. Function, then within square bracket you can have row, then r h, the row f h, row f h. This is a vector within a square bracket, so that is a vector or a matrix. So multiple values can be returned in the MATLAB. This is not possible with C or Fortran. So these are two important things that you must remember about function definition. Now let us try to see what else we know about function file. Name of the function file must be the same as the name of the function. So this is always case sensitive, which means it can be if it is capital letter or small letter, combination of capital letter, small letters, it is always sensitive to that. So MAT, so suppose you are defining circle, you are designing a function circle. So capital C IRCLE, that is one function. If you write small circle, that will be another function. These two functions will not be same. Now you may write capital C or all capitals circle. That is another function. C capital, I small, R capital, C small. So this way if you write, that is another function. So this is case sensitive. For example, you see function theta is equal to THETA Now what is the name of the function here? Capital THETA. On both sides you can see that there is theta, but on the right hand side it is capital THETA. Left hand side it is small. So output is small THETA. That is different, but function name is capital THETA. Its file name should be capital THETA .m. Similarly, you can design any function. This way you can give names to the functions, different functions. Now let us look deep into the function file. Suppose we have function x out, y out. So two outputs from the function file. File name is, or function name is function name. So func a name, function name, and that represents the function name. X in, y in, these are the two inputs. So two variables are input, two variables are output. Now for that, let us write percentage func name, func name. This is we are going to compute a function. Okay. Write online help command. This is also a command line, a comment line. Include your name and date that you can do. Then x is equal to BLAH. Y is equal to more BLAH. BLAH may be defined earlier. So x is equal to BLH, y is equal to more BLH, that again defined. X out is equal to something in terms of x, y out is something in terms of x. We have not written that, but that can be something. So this is how you are going to write a function file usually. First line will be the line function, then within square bracket output variables, that is equal to name of the function, within bracket input variables, then write what is function name, what you are going to compute, write that we are going to compute this, then write online help command, then you include your name and date. So because you are developing this function, so include your name and date there. Okay. Now execution of a function or executing a function file. If the function is defined as function row HF, that is the first function that we saw, is equal to motion xy2, then this function can be called or used as you can see this RANG force. Now compare this line with the second line, fourth line with the second line. In the second line, we are defining a function row HF. Right. So our variables from the function which are output, the function is going to give you the three variables, three outputs. So here those three outputs are R, angle and force, RANG force. So that is equal to again your motion is the name of the function, so you write motion, then xt, yt and time. So if you have a defined xt earlier, yt earlier and time earlier in your script file, that will be taken as input, that will go to the function motion. In the motion it will be evaluated, then its output, which is row, will be R, H will be ANG, F will be force. So R will be mapped to row and ANG will be mapped to H, force will be mapped to F. Or you can straight write motion to 3.5, 0.001, or you can put any number there, 5, 4.6, 0.1, and those like that. You can write that. That is going to give you the output for the function motion, but it will give you a row matrix which has 3 columns. You can use function as an argument for another function. So the name of the function is passed as a string quoted with single quotes. So within string and character, they are always to be within single quote. For example, you can write integration of sine 0 comma 1 sine. Now you can see the function is sine function. So what we are doing here is you are giving a command which is going to integrate sine function from 0 to 1. So sine is within single quote 0 to 1, and integration is the name of the function. That function you have to define. Either it is defined by the within the MATLAB, whether it is an inbuilt function or an extrinsic function you are defining it. It depends. You have to choose it. Usually ODE is the function for integration. ODE4 is the function for integration. But you can write an integration formula using trapezoid rule or Simpson rule. For that, write a function, integration function. So integration of this. Function as an argument is FEVAL. F evaluate, function evaluate. FEVAL is function evaluate. So function evaluate, this evaluates a function whose name is specified as a string. Now a string is always passed as an argument list. Now let us see an example. FEVAL evaluate sine 0.3, which means it will evaluate sine within bracket 0.3. So sine 0.3 can be evaluated using this way. This is same as sine 0.3. So either you write sine 0.3 or you can write FEVAL sine 0.3. So that is FEVAL, how you are going to use FEVAL. For sine you will definitely not use it, but for your function sometimes it will be required. If you have defined a function yourself, then sometimes this will be required to evaluate it. So that is something that is important. Then let us go to an example, integration example. So let us start with a function definition. So function res is equal to integration fab. Res is for result, short form for result. That is what we are using here. Function. So integration, it will be integrating the function f from a to b, and the result will be the output. So you can write something is equal to f eval fx of function x. Function will be evaluated for the value x, feval. So this way you can uh, straight away write the integration formula using Simpson rule or trapezoid rule. Now how you are going to, so once you have defined the function, how you are going to use it. So for using it, you can write integration sine 0, comma 1. That is what we have shown earlier. Then some features which are language specific. Let us see some features which are language specific. Usually you will use comments to create online help or H1 online. So these are two times you can write. Then a line continuation, as I told you last class. So if your line is very long, you want to fit it within the screen. So write up to 20-30 characters, then put 3 dots, then continue it in the second line. So line continuation is that. Global variables in a function. Suppose you are using a function x dot is equal to ODE1 tx. Then ODE1 is a function to do certain thing. ODE is usually ordinary differential equation. You are going to solve the ordinary differential equation sort of thing. Now you can write global. The moment you write global, anything that follows that becomes a global variable. So global k value, c value. Now these two values, k value and c value, are going to be global variables. So then you can write x dot is equal to k value plus something, or k value into something, whatever you want. You write that. When it is returned, when the function is called, ODE1 is called, it will return x dot, but it will retain the k value. So after the calling the function, if you go to the command window and write k value, it will write the k value that has been evaluated within the function. Usually, unless you write the global part there, k value will be extinguished after you come out of the function. But if you have written global, then k value will continue to be as it is, as it was evaluated within the function. So this is basically a general introduction to how to write simple programs or general examples, simple examples of writing simple programs. I hope you can use this uh, further when you uh, write your programs or when you uh, try to execute or try to write a program for the examples that we discussed last time or for the exercises. So let me take a break of 1 or 2 minutes. Then we'll come back and go to the next part. Now let us look at some important aspect of writing a program, whether it is C program, whether it is a Fortran program or it is programming using MATLAB. You require three things for most of the programs. One is looping, one is branching, one is uh, control of the flow, of the program flow. So loop means you are uh, executing the same command over and over again. Branch means you are executing a set of program, you are going through a line, particular line, but under certain conditions you have to deviate from it. So you go out from that. So there are two ways. Either you go in the path A or you go in the path B. Or under certain conditions, if a certain condition is met, you have to go through part A and part B. Either of these two or both of these. So that depends. So you have to make a decision. That is another one. And flow means that you have to see the example. With the example you will know what is flow. Flow means under certain condition I will do this, then next condition I will do this. If the condition, suppose uh, if x is equal to 1, uh, y is equal to 5. If x is equal to 5, y is equal to 10. So, and you are going to use what is y uh, in the program. So this is the flow. So there will be no uh, hindrance in designing phi or defining phi. Earlier you have to define that, so the flow will be automatic. Okay, so let us start with the loops. Let me go to the for loop, which is the most common one. Example is for m is equal to 1, 200. This colon means 1 to 100. 1, then in increments of 1 you are going up to 100. 1, 2, 3, 4, 5 up to 100. So 100 times m is equal to 1 to 100, and you are going to repeat it 100 times. So while m is equal, for m is equal to 1 to 100 means for m variable is m. When the value of m is equal to 1, you will execute the commands below that line. When m is equal to 2, you will execute that till m is equal to 100. You will keep on executing that value. So for m is equal to 1 to 100, when m is between 1 and 100, both inclusive, inclusive, that is close bracket. So both inclusive, the commands below this line will be executed. Now let me write a simple command. Ym is equal to sine 1 upon m. So y1 is equal to sine 1, y2 is equal to sine half, y100 is equal to sine 0.01. Right? So every value of y you will find, 100 values of y you can find using this. Then how do you know that it will end? So just put a end sign there. So start with for, end. So the moment you write for something, then end. You always make a practice of this. For, write something, then end, then go back to for and write the programs. Now you can see there is a tab in for and end. They are on the same line, vertical line, but y is slightly shifted. Why we do that? That indicates that it is within the for loop. Within the for loop, there is another for loop. So for that, again you will shift it, so it will be easy to find out y is in which for loop. So that is why we do this, but it is not mandatory. This is optional. It's a good practice. It is optional. You can do always this. Okay. Then and there is another example here. For n is equal to 100, then colon, then minus 2, then colon, then 0. Now what does that mean? That means n uh, uh, is varying from 100 to 0. So you start at n is equal to 100, you go to n is equal to 0. Now 100 to 0 you will go by decrement. So decrement means you have to subtract from 100, you have to subtract. So it can be 100 to 100 colon 0 will be not acceptable, because if you give only a colon there, then it indicates, as in the previous case, 1 colon 100 means it will be incremented by 1. That is default. Now you give 100 colon 0 incremented by 1, and it will be 101, 102, 103, etc. So you cannot never reach 0. Therefore you have to give 100 colon minus 2 colon 0. So the moment there are three things there, then it understands that I have to follow this increment or decrement. The middle one is the increment or decrement. Okay. K is equal to something to end. So that you can also write. This is another way of writing the program, or another way of writing the for loop. Now you can see in the previous one and this one there are two differences. One is there are three lines. For m is equal to 1 to 100, then there is no comma, but you come to the second line. ym is equal to something that you read, right? Then you come to the third line, there you end. Whereas in the second line, the difference is for n is equal to 100 to 0, then there is a comma. That means you are going to continue the for loop there in the same line. So in the first line also, after 100 you can give comma, then you can write ym is equal to sine 1.0 by m, comma n. That you can do. The same thing is done here. In one line you can write it. But this I usually do not advise people to do this way. It is always better to write it line by line. Okay. Now if I do this one, then you will have n runs over 100 to 0 by 100, 98, 96 to 1, 0. That way it is going down. So this is about the for loop. There can be a for loop within for loop. Those things will come later. Then the while loop. The next one is while loop. Suppose we say number is equal to 0. NUM stands for number. Number is equal to 0. V is a variable that we define as 1. I is a variable that we define as 1. Now remember this, that the moment you put a semicolon, that indicates two things. The first thing that indicate is you are suppressing its uh, visibility. So it will not be visible in the command window. M is equal to 0, number is equal to 0 will not be visible in the command window. That is first thing. Second is, it says that your statement has ended and you can start a new statement there. Therefore, we have started a new statement, v is equal to 1 semicolon. Then we have started another new statement, I is equal to 1 semicolon. This you can also write as num is equal to 0 semicolon, next line v is equal to 1 semicolon, next line I is equal to 1 semicolon. So that you can write. Now once we do that, then we'll say that while number is less than 10. Now 0, now we have defined number is equal to 0. 0 is definitely less than 10. So write this way. While number is less than 10, number is equal to number plus 1, which means in the second line now number will be previous number, the number that was defined earlier, 0 plus 1. So now the number becomes 1. V is equal to V star 2 to the power number. So V was 1, so V will be 1 into 2 to the power 1. So 1 into 2. So V will be 2, new value of V will be 2. So this way you can define I will be something that, and once you have defined everything, this will end. So this will continue till n becomes 10, which means it will start first time it will be a number is equal to 0, so that will be executed. Then second time it will be executed because number is equal to 1. Third time it will be executed, number is equal to 2. Fourth time it will be executed, number is equal to 3. So this way you will go till number becomes 10. When number becomes 10, it is 11. So it will be executed 11 times, not 10 times. Remember this. It will be executed 11 times. So this is how you are going to use a while loop. It is slightly different from for loop. In the for loop, you say that you execute it for this number of time, whereas in while loop, you put a condition under which it will be executed, like number is less than 10, or you can say while number is greater than v. So all those things you can always do. Then comes the if else if statement. If else if and if else if else statement. If I is greater than 5, then execute the following: k is equal to I. Else if I uh, else if I is greater than 1 and j is equal to 20. So what does this mean? If I is greater than 5, then k will be I. No problem with that, that will be done. But if I is not greater than 5, then again choose or search for whether I is greater than 1. If I is greater than 1 and at the same time j is equal to 20, these two are satisfied, then the next line will be executed instead of the first line. K is equal to I, there will be no k is equal to I. If I is not greater than 5, k will not be equal to I. But if I is greater than 5, k will be equal to I. But the moment I is greater than 5, it will not go to the else if statement. Because I is greater than 5, the first one will be executed. If I is not greater than 5, it will come to else if statement. So else if I is greater than 1 and it is considering j is equal to 2, logically equal to 2. It can be only else if, it can be else if I greater than 1, that also can be there. It is not mandatory that you will add and j is equal to 2. If it is required, you add it. If it is not required, you don't add it. And then k is equal to, this is how you define. Else, if these two are not correct, otherwise, if I is not greater than 1, I is not greater than 1, then k is equal to 1. Or I is not greater than 5, I is greater than 1, but j is not equal to 20, then also k is equal to 1. So this is how you define an if-Elseif-Else statement. After the else you will end. So start with if, always put this end. Don't forget to use end when you are using a loop or branching. This is what is branching, as I told you. Now you are branching out. If I is equal to 5, you are going in a particular direction, k is equal to I. Else, so you are going in a next direction. Else if you are going in the next direction. Else you are going in the next direction. You can have as many else if statements, as many as is required. So we have shown one example here. In this example, it shows only one else if. You can write else if I greater than 3, then k is equal to 5. Else k is equal to 1. That also you can do. And now let us come to switch case otherwise. This is another way of branching or flow. This is but particularly flow. Switch case otherwise. A switch flag, we are saying the uh, okay. The syntax for this is switch, then give a flag. What will the flag that will see? Case. If that flag is satisfied, case is you give the what will be the value. Then block 1 is under that case. Then case 2 will be another block. So this way you can go up to 3 or 4 cases. Then otherwise, finally you will go to otherwise, then block default, then end. Otherwise, otherwise you will say what will be the flow, then end. So this is the flow. Let us see one example for this. Switch color. So you are switching the color. Okay, switch color. Case red. If color is red, now what you will do is you will keep on switching the color. So first we will consider red. If color is red, then say is equal to 1, 1 0 0. If case means color. What is the color? Color is green, then C is equal to 0 1 0. If a color is blue, then C will be 0 0 1. Otherwise, there is error. You can write error. Invalid choice. So if the color is neither red nor green nor blue, then your choice is not valid. So suppose color is yellow, then it is not valid. So before this or after this, you can write yellow. Sorry, before this you can write yellow. So yellow means it is invalid color. So this is how you do the flow. Okay, and then there is a statement or command break. The command break inside a for or while loop terminates the execution of the loop. So if you are in somehow you get into an infinite loop, then you can use the command break, it will terminate it. Unlike C and C++, there is no need to break in the switch statement. We don't require a switch statement here to put a break. Straight away write a break command, it will automatically break that uh, or break that loop. Then the return statement. Now let us look at a function. Function animate bar t0, tf, x0. This is a function, some function with three input variables, and there is no output variable. So it has only three input variables. Okay. So animate bar, it does such and such things. Okay. Display, do you want to see, because you are going to animate and you want to see the animation. So display, do you want to see your answer. This ans is your answer. For display is this will be displayed on the screen. The screen will show the moment you run this function. The screen will show display. Screen will show, do you want to see. Then you have to give an answer, either yes or no. So answer is input. The input means you are going to give the input. So what you will input is enter 1 if yes, 0 if no. So if you write and do you want to see, the moment you see on the screen, do you want to see, then write 1, enter, it means you want to see. Answer is yes. Uh, or 0, enter means you don't want to see. So answer is no. Then it writes, if answer is not equal to 0 or answer is equal to 0, then return else plot. So if you don't want to see, it will go out of the function. Return means return out of the function, it will not execute the function. Otherwise it will plot your xy, plot xy. So you want to see, so there is a plot command. The moment you give the plot command, you want to see whatever is there in the plot, you will see. And so this is if. So you are using if, answer, return, else, end. So if, else, end is there, and return function is there. Okay, then how to use interactive input. I just show you one interactive input. Do you want to see, answer is equal to input. So input is the command for interactive input. Okay. So input string, string is whatever you want to give. Print the string and wait for the user input. I will just give you one example here. I just gave one example there. Here n is equal to input, enter a number n semicolon. You can n colon, you can give the colon, you may not give the colon. Then a quote mark. So within quote, single quote, you put enter a number n. So you can write x. Suppose you are writing a program. As I told you, you are writing a program. I gave you an example for Fahrenheit conversion, centigrade to Fahrenheit. So in the program, you can write C is equal to something, but that will be fixed every time you want to change C. You will change the value, or you will change the program. Now instead of that, you can write C is equal to input, then enter temperature in centigrade, semicolon, then quote mark with brackets ends. So that way, in the moment you write the program, run the program, computer will ask you on the screen, you will see enter the temperature in centigrade. So then you can give the value of C. That value of C will be accepted by the computer, and that will be used in the program. Okay, so this is one example. Then more is equal to input, more simulations, yes or no. So within quote mark yes, within quote mark no. That you can see. More simulations, yes or no. Now here the input will be a string, either yes or no or yes. Okay. So this is the first one is input of a number. Second one is for input of a string. Then let us come to the keyboard command. The keyboard command, this returns the control to the keyboard from the script or the function. So if you are writing a script, inside that you have written keyboard, automatically it will come to the keyboard for giving a command. Or in the function you can come to the keyboard. And type return makes control back to the script. So you come back to the keyboard, whatever you want, command you want to execute in the keyboard, in the command window you do that. Then in the keyboard write return, so that the moment you give the return command, you will go back to the script, so it will start writing the script, etc., or it will execute the script or execute the function. Okay. This is usually used for debugging. If you find that maybe my program has some error, then after every 5 lines or 10 lines, write this keyboard and search whether there is an error. Then give return, it will come back to the next line, 5 lines. So first 5 lines you have checked, then next 5 lines you will check, so that way you will find out where the error is. So that is another useful thing in writing the Fortran program, keyboard and return. Then the menu. Menu is used as like this. Coordinate is equal to menu. Menu name ABC. So name of the menu are ABC. So you will create a menu choice with menu name, and 3 buttons labeled as ABC. And the 3 button written values coordinate is 1 for choice A, 2 for choice B, and 3 for choice C. This is basically if you are preparing a question, objective type question, and with 3 choices, ABC or ABCD. So this will be that. Okay. And then you can also have input output in style of C or C++ language. So MATLAB supports most of the or many standard C language file and input output functions. Therefore, it is very easy to integrate MATLAB and C. To make it faster, you can integrate it with C. Like fopen, this means open a file, a new file. Fclose, close a file which has been opened already or which is already open. Fscanf, this is read from a formatted file. Then fprintf, write a formatted data. Then fgets, reads a line. So F means file. F, the first one, first F is first file, then file open, file close, file scan F, second F is formatted. Scan means scan the file which is formatted. Then print F, print is print, F is formatted. Then file gets means read from a line, get it from a line. And then there are advanced things like multi-dimensional array. You know, array can be single dimensional, one dimensional, which is, as I gave you an example, a is equal to 1, 2, 3 within square bracket. A is equal to 1, 2, 3 within square bracket. This is a single array, single element array, or sorry, it is in a single row array. Many columns, so 3 columns. You can have n number of columns, single row array, one dimensional array. Or you can say A is equal to 1, 2, 3, 4, 1, 2 semicolon 3, 4. It is a 2 cross 2 array, it is a 2-dimensional array. Or you can say A is equal to 1, 2, 3, comma 4, 5, 6, comma 6, 7, 8. So it is a 3-dimensional array. So similarly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all separated by semicolons. That will be a 4-dimensional array. So you can have n-dimensional array. So this is an example. A, this is the element number 442 is the element number in a 3-dimensional array. Okay. So you can have multi-dimensional arrays easily here. Then if you are acquainted with structure in C, the same principle is also applicable here. Fall semester dot course. So then fall semester dot professor dot prof. So it is about fall semester. Structure is fall semester. Within the fall semester, for you can say odd semester, even semester, third semester, so anything. So you define a structure. Third semester contains many things. You have course, so course 1, course 2, course 3 can be there. Then professor or teacher, so who is the teacher for this course 1, who is the teacher for course 2. Then scores, so the marks you have got in the fall semester. So those things can be structured. You can structure those things. And then sales. Sales you are not going to use. So uh, initially you will not use sales. So I will not go into this. We will see this later. And finally I will come to another example. uh, Give you an exercise, not example, give you an exercise for the next class, and then we'll discuss about what you have done in the last class, whether you have been able to do the exercises or not. If there has been any problem, we'll discuss those problems. The exercise you have to take is this: define a function that asks the user to enter a sequence of numbers, sorts the number from ascending order, returns the sorted numbers. So these are the three things that it will do. First, it will read a sequence of number. Suppose 10 numbers. So 1, 5, 8 this way, 100 this way. It will take 10 numbers. Then sort them in ascending order. Then return that sorted number. So it will make a vector in which these are sorted in ascending order. Then it will be, so ascending order means smallest number first, largest number last. Then it will return that matrix. So you can see that okay, it is sorted in ascending number. So with this we'll end on this lecture, today's lecture. I hope we had some fruitful discussions, and you have been able to understand certain things about MATLAB. Now, once this is over, since this is over now, we can go back and return or discuss about the exercises that I gave you last time. And if you have any problem or if you have any doubts, that we can discuss any point that you raise, that we will also discuss now. Little recording the କିଏ କିଏ କରିଛ ଗଲା ଥର ଯୋଉ ଦେଇଥିଲେ ଏକ୍ସରସାଇଜ, କିଏ କିଏ ଚେଷ୍ଟା କରିଛ? ଆଉ ଯଦି ଚେଷ୍ଟା କଲ କଣ ପ୍ରୋବ୍ଲେମ ହେଲା, କେତିକି ବାଟ କଲ, କଣ ପ୍ରୋବ୍ଲେମ ହେଲା,